Okay, are you all ready for some final review? So here's the plan for today. I got two questions prepared. One is the optimization problem, and the other one is a related race question. Okay? We are going to do the optimization problem first. Okay? So I realized there was a lecture video for the optimization question, and I guess since I'm not the person that made the video, some of you were a little unfamiliar with the lecture style for the other instructors. So I'm going to take this question as an example to explain how to do optimization problems in general. Okay? But to start, why don't you take 2-3 minutes to first read the question and try to understand what the question is asking first. Okay. Did you all finish reading the question? Okay. So here's what I'm going to do. I'm going to pretend I'm the one taking the final. Pretend I never looked at the question before. And I'm going to show you my thought process on trying to solve this problem. Okay. So the first part of the optimization question, again, let me just say the optimization questions, they're a little harder than the usual questions, the other type of questions, because it's not like someone give you an equation and just ask you to, here, take the derivative of this, here, do this differentiation. There are words, right? You have to first read it and try to understand the math behind the question, and then you write down some algebraic expressions. Okay? So there's a step that's needed in order to convert this bunch of words into some mathematical expression. So that's the first part for these kind of problem-solving word problems. Okay? So here's I read it. Copper is standing at the west point of the lake with radius 120 meters when he spots the duck cross. I'm like, okay, so copper is where's copper? I read it, you're like, oh, copper is actually a dog. I guess it's a he too, right? But the question never tells you that copper is actually a dog, right? So you can only tell that from the picture. So here's copper. Anyway, the important point is that the radius is 120 meters. So that's 120, this is 120. They're all about the radius. Okay, so I'll label that. That's the first part. Now, to get to the duck, there's the duck. He can swim or run around the lake. Okay, so you swim at a speed of 6 meters per second. That's important information. So what I do is I just circle it. Swim at a speed of 6 meters per second and runs at a rate of 12 meters per second. That's important information. I'm also going to circle that. Okay. Now, if he swims to point B in a straight line, okay, let me read it. Let me see if he's here. He swims to point B in a straight line and then runs around the lake from B to C. Okay, so he first swims in a straight line and then runs around from B to C. Then he's gonna catch the duck, right? That makes sense? So the question is asking, find the angle theta. There's theta. I look at the diagram, which will minimize his time to reach the duck. Okay, so that's what the question is asking. Okay, there's the angle theta here, which we're supposed to find, so that the time it takes for him to catch the duck by first going swimming like this and then running around is the minimum. Okay, so that's what the question is asking. Then I think to myself, does that make sense? You're like, yeah. If you try to catch the duck, he wants to do it in the minimum time possible. Okay, so that's the question. Does that make sense? Does my thought process make sense? You just have to convince yourself the question makes sense to you first. So the first step to solving the optimization question is to write down the expression that you're supposed to minimize. Write down the expression that you are supposed to either minimize or maximize. In this case, whatever expression we write down, we're supposed to minimize it. Okay? And the expression we write down should be the expression for the time it takes for copper to get to the duck. Okay. Does that make sense? So here what I need to do is I need to write down the expression for the time. Okay? So how do I write down the time? Well, time is distance divided by speed. Okay? Now here there are two paths. The first path is swimming from A to B. Okay? So the time it takes to do that is the distance from A to B divided by the swimming speed, which is 6. Okay? So that's the first part. Okay? So I write time is equal to AB divided by 6. And the second part is the distance of the arc between B and C divided by the running speed, which is 12. Okay, so I'm just writing as the arc length BC divided by 12. Okay, so that's an expression for the time. Does that make sense so far? Okay. Now, none of this is very hard to write down yet. Okay. Now, what I need to do now is that I need to write down this expression or convert this expression to a mathematical expression. Then I can take the derivative. So how do I do that? So in order to do that, I need to figure out what is the mathematical expression for AB and what is the mathematical expression for BC. That's what I need to do. Okay. So let's try to figure out what is the length for AB first. Okay. So AB is here. I'd like to figure out what is the length for AB. Okay. Now, how do I do that? Okay. So here's what I do. Okay. Now, AB is part of a triangle, right? This is A, B, and the center. Okay. I want to try to figure out some stuff about the triangle. What are the side lengths and what are the angles? Now, the side length for this triangle, one side length I labeled as 120. I claim this length is also 120 because that's also the radius. Okay. And this angle here is going to be 180 minus theta, right? Because that's theta. The whole angle here is 180 degrees, or pi. So this here is going to be pi minus theta. Okay. Does that make sense? So that's the information I have. Okay. Now, in order to find the length AB, here is what I find an easy way to do it. Okay. So an easy way to figure out what AB is that I look at this triangle. This is an isosceles triangle, which means that these two lengths are equal. And what I can do is I can divide this triangle into two right triangles. Okay? So I can draw a line straight down the middle, divide this triangle into two right triangles. Okay? And for each of these right triangle, the angle is going to be half of the this pi minus theta. So the angle here is going to be pi over 2 minus theta over 2. Let me just zoom in a little bit more. Okay. Does that make sense? Okay. So if I know this angle here, pi over 2 minus theta over 2, and I know the hypotenuse, which is 120, I can figure out what's the opposite. Okay. What's this length here? This is just going to be 120 times sine of pi over 2 minus theta over 2. In other words, I can simplify this a little bit. It's 120 times cosine theta over 2. Because sine of 90 degrees minus an angle is just cosine of that angle. Okay. So far, so good? Okay. And the same argument is going to apply to here. Now, this length here is also going to be 120 cosine theta over 2. Okay. So what this means is that the whole AB is going to be 240 cosine theta over 2. So AB is going to be 240 cosine theta over 2. And I divide it by 6. Okay. Sounds good? Okay. Now, I did say that, this is the test like exactly 2 years ago. I was teaching Math 124 that year too, so I did not propose this question, but this is the question I graded. During the grading process, a lot of the students have trouble finding AB because there's no like a direct formula that tells you what AB is. It's not like some formula for arc length or stuff like that, or area of the circle. You have to do some geometry to figure out what AB is. Okay? Some of the students got stuck figuring out what AB is. But finding it is not hard. You just have to draw the right lines and see the right triangles. Okay. Any question about this so far? Okay, very good. Now let's figure out what BC is. BC is easy. There is actually a direct formula to figure out what BC is. This is the arc length, and there's a formula telling you that the arc length is the radius multiplied by the angle. Okay. So there's a very nice formula that tells you the arc length is equal to the radius r times the angle theta. Okay. So in this case, BC is going to be the radius times which is 120 times theta. And I divide that by 12. Okay. So that's the expression for the time. Let me simplify it a little bit. So I can cancel out a 6 here, and this becomes 40. So this is 40 cosine theta over 2, plus 12 cancels out. This is a 10 theta. So this is the expression I'm supposed to minimize. Does that make sense? Okay. I'm going to give this function a name. I'm going to call it t of theta. T stands for time. And I'm supposed to minimize this. And this is the first step. There are 2 steps for optimization questions. This is the first half of solving optimization questions. Is to read the question, understand what the question is asking, and find the expression that you're supposed to minimize or maximize. Now, for optimization questions, is also you need to also write down the constraint. The constraint is very important. So here the constraint is that, well, theta is going to be the variable, but how small or how big can theta be? Okay, so here, from the picture, you can immediately see the smallest value that theta could be is 0 degrees. That means copper is just going to swim right across for the duck. And the biggest value for theta is 180, or pi. So here, that means copper is not swimming, just running around the lake to get to the duck. Right? So the constraint here is that theta has to be between 0 and pi. Okay. This is very important. This is the constraint. Okay. You're going to need that later on. Sounds good? Okay. So now that we have the expression, we have the constraint, the next step is to, when in doubt, take the derivative. We would like to take the derivative and figure out the critical number for this expression. Okay. So let's take 5 minutes, take the derivative, and see if you can find the critical number. And from that, see if you can figure out what the answer is. Okay, let's do this together. So I had this expression here, and I took the derivative. So I take the derivative as 40 times minus sine theta over 2 times a half plus 10. Okay, I simplified this a little bit. It becomes minus 20 sine theta over 2 plus 10. So that's the expression for the derivative. I set it equal to 0 to find a critical number. And when I set it equal to 0, I have sine theta over 2 is equal to 10 over 20, which is a half. Okay. So that tells me that theta over 2 is equal to pi over 6, or 30 degrees. In other words, theta is equal to pi over 3. And this is my critical number. Any questions so far? I have a question. Sine of theta over 2 is a periodic function. There are actually infinite many values for theta over 2 that gives sine of that is 1/2. How come I only set theta over 2 here to be equal to pi over 6? Yeah?
Because any other one is not in the domain.
Very good. That's my domain here. Theta has to be between 0 and pi. Okay? And this value is the only value so that the theta is in between 0 and pi. So for example, there's another value here, say 5 pi over 6. Sine of that is also equal to a half. But if I multiply by 2, I would have theta is equal to 5 pi over 3. That's outside of my range. Okay? And if I plus 2 pi, the theta is also going to be out of the range. So this value, pi over 6, is the only value here so that theta lies within the range. Okay? So this is one that you really need the constraint here. Okay, very good. So theta is pi over 3. Okay, that's my critical number. Are we done? So I told you I was grading this question. Some of the students back in the days, 2 years ago, I guess they will be juniors or seniors now, mostly juniors. They got to this answer, they boxed it, and they're just like, hey, we're done. We found the expression, we took the derivative, we found a critical number, all good, very nice numbers, pi over 3, that gotta be the answer, right? They box it, and we're like, yep, I'm done. Time to move to the next question. Turns out, the work they have done is 95% correct. Okay? Everything they have done, this is like the hard part at this point is all over, right? But it turns out if when they box pi over 3, the answer in this question is actually not pi over 3. Pi over 3 is the critical number, but for optimization questions, a critical number may or may not give you the final answer. Okay? You have to figure out where the minimum actually occurs. It could occur at a critical number, or it could occur at the endpoints. Okay? And in order to tell where the minimum actually occurs, you have to plug in the critical number into the original expression. So I have to figure out what t of pi over 3 is, as well as t of the endpoints. Okay? This is very important. You have to do this. You have the critical number, and once you have the critical number, like 95% of the work is over. The hard part is done. All you have to do is that you have to plug the critical number and the endpoints back into the original equation to check which one gives the smallest value. Okay. So here, pi over 3 is a critical number. I plug that in. I also have to plug in the endpoints, which is 0 and pi. Okay. So I have to evaluate these 3 numbers and compare them to see which one gives the smallest value. Okay. So what's my original expression? That's this thing here. I do 40 cosine pi over 3 divided by 2, so that's pi over 6, plus 10 times pi over 3. I punch into my calculator and I figure out what that is. Can anyone help me out? Does anyone have a calculator that already did it? Yeah. Well, someone punch into the calculator and tell me what they get. You got 25 root 3 for the whole thing? But there's a 10 pi over 3 here. I mean, this is square root of 3 over 2, so you get 20 root 3 plus 10 pi over 3. Well, while you're punching it out, let me write down the other expressions. The second one is 40 times cosine 0 over 6, which is cosine 0, plus 10 times 0. So this one is easy. Cosine 0 just equal to 1. This gives me 40. Okay. The third one's 40 times cosine pi over 2 plus 10 times pi. Okay. So all I'm doing is I'm plugging these values into my original expression that I got. Okay. And here, cosine pi over 2, that's equal to 0. So here I just get 10 pi, and pi is approximately 3.14, so 10 pi is about 31 times 4. Okay. Now, did anyone of you punch into your calculator yet? Anyone? Yeah.
Yeah, I got around 45.11.
45.1. Yeah, very good. 45.1. Okay. Now, these are the answers we need. Okay. Now the question wants us to minimize. So we need to pick out which of these numbers is the smallest. And you can see that this number is actually not going to be the minimum. In fact, this critical number is going to give us the local maximum. Okay? Because if you analyze the sign of the derivative, you're going to find it's increasing to the left of this number and decreasing to the right. So this one is actually going to give you a local maximum. It turns out the right answer is the last one here. Okay? And so theta needs to be equal to pi in order to give you the minimum. Okay? And you ask yourself, well, what does that correspond to? If theta is equal to pi, that means the dog is not even swimming to get to the swimming at all. If theta is equal to pi, that means the dog is running around the lake to get to the dock with no swimming. Okay? So theta is equal to pi, which means copper runs around, no swimming. Okay. This is a very important feature of optimization questions. Is that the first step, in summary, you write down the expression you're supposed to min-max, and after you write it down, you take the derivative and find the critical numbers. Okay? And after that, 95%, the hard work is done. But to finish off the question, you have to plug the critical numbers as well as the endpoints back into the question. Okay? You have to be very conscious of your domain. Okay? So the endpoints are always very important for the for the optimization questions, because I would say half of the time the answer could be the endpoints. Does that make sense? Yeah.
How did you get the domain again?
The domain is that you kind of just have to read the question, understand it, and for example, I look at this diagram. The diagram it says theta is here, right? So I ask myself, what's the smallest values for theta, and what's the biggest value for theta? I mean, theta, the way they drew it, theta can't be a negative number, right? And it also doesn't make sense for theta to be like bigger than 180 degrees. The way they want it, theta has to be, the smallest could be is 0, and the biggest it could be is 180. So this is how I got the domain. Yeah, question?
Do we have a seating chart on Saturday?
You will have a seating chart on Saturday. I told the head TA to make it, so you should have it available on Friday. So it's like when you take the plane, there's a plane ticket. You have your seat number in there. Yeah. Okay, any other questions for this question? Yeah?
What do you do if you don't have a calculator?
You need to have a calculator. In this question, calculator is required for the very last step. Okay? You do need a calculator. I joke around saying bring the calculator as a good luck charm. That only applies for my midterms. I make my midterms. I make it so that you don't require a calculator. But for the final, there are questions you definitely need a calculator. Okay. For example, this one. Okay. So make sure you get your calculator. All right. So if there are no questions, we're going to get to the course evaluation. Remember, there are two ways to improve your final grade. One way is to prepare really hard for the final exam. which you should all be doing. There's another way is to fill out your course evaluation and get the class response rate to greater or equal to 70%. I checked before class. Right now the response rate is 52%. We're close. We just need 18 more percent. So why don't you all pull your laptop or phone if you haven't filled it out yet, and let's take 5 to 10 minutes filling out the course evaluation. You know, whenever I ask my student to fill out the course evaluation, it's always like, you know, when you watch these YouTube videos, like the guy is just like, I mean, in the middle, the guy always inserts some ads, and because he had to make money, I guess. And then he was like, oh, if you like my video, give me the thumb up, leave your comments down below, subscribe, and make sure you click the bell on, all this, all that. Anyway. Hmm?
Half the points are given to us if we do the evaluation. So
Yeah, that's right.
and then if you set up the problems, it's like you get it wrong.
Sine pi over 2 minus theta over 2 to cosine.
It's because if I have sine of pi over 2, which is 90 degrees, minus any angle, that's the same thing as cosine of that angle.
Okay.
You can see that from by, say this angle is x, this angle is going to be pi over 2 minus x. Right? Sine of x is going to be the opposite over hypotenuse. But to this angle, that's the adjacent over hypotenuse.
Yeah,
So
I see. I mean, it still works with this one. It just takes.
It would work, yeah.
Yeah.
But I try to make the expression as simple as I can. Yeah, it's still gonna work if you don't do that. So for the course evaluation, there is one for me, and there is also one for your TA. Make sure you also fill out the one for your TA as well.
Yeah, she can tell. Yeah, but where am I right now? We should go back to
Okay, gonna give you one more minute, and then I'm gonna move on to the next question. All right, let me press the refresh button. See where we're at. Wow, 80%. You got it. Okay. +5 on the final for everyone. Yes, we did it. Okay, let's look at the next question. So this question is a related rates question. Has a very similar feel to optimization problems. So on your test, the related rates and optimization questions, they all require words, right? And you have to read it and understand what it's saying first. And sort of the hard step is to set up the equations. Okay, set up the variables and set up the equations. So this question, we're going to read it together. I'm going to try to figure out what to do with it. Okay, and I think this question is a very good question because once you see what to do, it's not hard. It's not very difficult. But this question is like the diagram is not. Many of the students 2 years ago didn't see this diagram. So when they see it, they're just like, whoa, what's going on? Okay. So let's read it together and see how we can make sense of this question. Okay. So let's read it. So Retta runs at a rate of 4 meters per second around the circular track of radius 50 meters. Okay, that means I can label something. Retta's here. Retta's running this way. Okay, 4 meters per second. Let's label that 4 meters per second. Okay, and the radius is equal to 50. And in this question, the problem's already the diagram already labeled that for us. So the radius is equal to 50. Okay. Now at the center of the track is a light bulb. There's a very nice light bulb here. It's shining, and it's 10 meters away from the track. Okay. So there's 10 meters away from the track, there's a wall, okay? Now, here's what the question asks. When Retta is 35 meters from the wall, how fast is her shadow moving along the wall? You're like, oh, okay. So Retta is 35 meters from the wall. That means this distance is 35. Let me label that. This is 35. And what we want is the speed of her shadow. Okay? So the shadow is at this position here. And what does it mean, the speed of the shadow? That means the shadow is changing as Retta is running, right? So let's understand the situation a little bit more by drawing some more lines. Okay? So how is this shadow formed? There's a light bulb here, and it's shining onto Retta to cast a shadow on the wall. So I want to draw this line. Okay? The light bulb is here. It's shining this way to Retta, and it's going to cast a shadow on the wall here. Now, as Retta is running across, for example, when she's here, the light is going to go to this point, and then cast a shadow over here. Okay? So what this means is that you can see from the picture, as Retta is running this way, the shadow is going to move this way, as the diagram is indicating. Does that make sense? And the way this shadow is formed is by connecting a line from the light source to reta and then intersecting the wall. This is the way the shadow is formed. Okay? Now, the first step to solving the related rates question, now that we've understand what the question is asking for, is to figure out what variables we should assign. Okay. So in this question, what variables should we assign to figure out how fast her shadow is moving along the wall? Okay. It's not obvious right off the bat try to figure out what variable to assign. It turns out in order to figure out what variable to assign, you have to draw some more lines. Okay. And the line you have to draw is actually this line. I would like to draw a line connecting the center of the circle to the wall, a perpendicular line. Okay. And the purpose of drawing this line is to give me a way to describe the shadow. Okay. Because once I draw this line, let's look at this distance here. Okay. The distance between the shadow and this point. I'm going to call this distance x. Okay. And my claim is that if I figure out how fast x is changing, that's going to be telling me the speed of the shadow. Right? Does that make sense? Because if the person is here now, the location of the shadow here, that means x is going to increase, right? So as long as I figure out how fast x is changing with respect to time, I'm going to figure out how fast the shadow is moving along the wall. So x is one of the variables I should assign. Okay. Does that make sense to everyone? Okay, very good. Now, for related rates, there are usually two rates. So what's another variable I should assign? Yeah?
The angle between the line from the shadow and the line to the wall.
Very good. The angle between the shadow and the wall. You're saying we should assign the angle here, right?
Oh, no, I meant
This angle? Very good. Okay. Very good. This angle. Very good. So I claim, very good. That's the second variable I should assign. Okay. Now I'm going to explain the reason I should assign this angle as the second variable. The reason is that knowing what this angle is going to tell me the position of a reta. Because once I know what this angle is, as reta is moving along the circle, this angle is changing. So this angle directly corresponds to where reta is on the circle. Okay. So that's my two variables. There's theta, there's x. I should also write down d theta dt and dx dt. Okay. Now this is a related rates question. I should figure out what do I have and what do I want to figure out. So dx dt, like we talked about, this is what we like to figure out. This is how fast her shadow is moving. Okay? And what I need to figure out is I need to figure out theta x and d theta dt, given the information I have. Okay? But before I do that, I would like to write down the relationship between theta and x first. Okay? Now to write down this relationship, I observe that this length here is 50 plus 10, okay, which is 60. Okay. And this is going to relate theta and x. Because if I use the tangent function, I get tan of theta is going to be x divided by 60. Okay, so this is the equation that relates theta and x. Does this make sense so far? Okay, now let's figure out d theta dt first. Okay, now to figure out d theta dt, I'm going to use this 4 meters per second. Okay, so the formula I'm going to use is that I'm going to use the formula we were using in the previous question. Is that if I have r times theta, that's equal to the arc length. Okay. In other words, if I divide both sides by r, theta is going to be the arc length divided by r. Okay. Now for this question, the arc length is changing at a speed of 4 meters per second, and r is equal to 50. So if I divide 4 by 50, I'm going to get how fast theta is changing. So theta, d theta dt, is going to be the change in arc length divided by the radius r. It's going to be 4 over 50, which is 2 over 25. This is something we learn from this very useful formula for the arc length. Sounds good? Now the next step is to figure out what is theta and what is x. I'm going to figure out what is theta first. Okay. Now to figure out what theta is, I'm going to draw an extra line. Here is the point you have to play around with this diagram. If you play around, it turns out this line is the correct line to draw. Let me draw using a different color. Okay. This line is the correct line to draw. Because once you draw this line, there's this very nice triangle here. Okay. And this triangle is nice because it's a right triangle. I know the hypotenuse. This is equal to the radius, which is 50. I also know what this side is. Okay. This side is 60 minus 35. Okay. Do you all see that? Okay. Which is 25. So this side is 25. So what that means is that I can set up. So I write cosine of theta is going to be 25 over 50, which is 1/2. Okay. That's a special trig angle. And that means theta is equal to 60 degrees, or pi over 3. Okay. So I get theta here is going to be pi over 3. Okay. And once I have theta, I would know what x is, because I have this relationship between theta and x. If I know theta is equal to pi over 3, then x is going to be 60 times 10 of pi over 3. So x is going to be 60 times 10 of pi over 3. And 10 of pi over 3 is square root of 3, so this x is 60 times square root of 3. And now I have all the information I need. Okay, I analyzed the diagram, which is not an easy diagram to analyze. I assigned variables, x and theta, and I figured out all the necessary information that I need. I have theta, I have x, I have d theta dt, and what I want is dx dt. What I have is the relation between theta and x, and the rest is what we always do for related rates. You take the derivative, and then you plug in all of these values and solve for the unknown. Okay. I'll leave the rest to you. Okay. The rest is an exercise. Okay. But the important lesson to learn is that on the test, you're going to see questions like this. You might see questions like this. You read it, and it's not clear immediately what to do, but you just have to stare at the diagram and do some guess and check, just trial and error, and eventually you'll be able to draw the right lines and solve the question. All right, this is all I got. Thank you for coming. I will see you all on Friday.